Hey, good evening, everyone. Are you able to see my screen now?
Yes.
Okay, okay, okay. In our previous session, we discussed about a few of the vCenter Server inventory objects. I just copied all the inventory objects in one of the spreadsheet. So, in our previous session, we discussed about WAMI page. What is the vSphere VMware vCenter appliance management interface? We verified and we also log in and verified all the options. And we verified in our vCenter server how to create the data centers and also how to add the ESXi host. We verified, and the cluster we just verified how to create a cluster, but we haven't enabled the HA and DRS switches because HA and DRS we have a separate classes for that. So I just shown you how to create a cluster also, and we observed VM creation and template creation, and the template also we have separate concept. During that time I will explain some real-time scenarios also. Okay, but options we are familiar now as of today. Now today's session we are going to start with the storage. It's a vSphere storage, same like our during the ESXi networking. Before understanding ESXi networking, we discussed the few basic networking concepts. Similarly, before start our vSphere storage, we will also discuss the some basic storage concepts. Once we are familiar with the basic storage concepts, it's easy to understand the vSphere storage also. Okay, but vSphere storage, it's supported only for two file systems. One is VMFS, another one is NFS. VMFS stands for virtual machine file system and NFS stands for network file system. Okay, suppose in our Windows operating system, in in our olden days, we can use the file system name called FAT file system, FAT16, FAT32, and latest file system in Windows is NTFS, New Technology File System. When it comes to the Linux operating system, previous file system is EXT3, Extended File Systems, and when it comes to the latest one, EXT4. So similarly, in our VMware also, it's supported for mainly two file system formats. Either you can format the file system with NFS or VMFS. Any format it will support for ESXi layer. Okay, so we'll start with the basic storage concepts first. So the agenda is basic storage concepts, and we'll also discuss the local disk storage protocols. What is the protocols we used for the local disks? Once we familiar with the local disk, we can also start discussing the additional types of storages. And storage types, mainly we have a three types of storages: block storage, file storage, and object storage. So these three storages will observe the use cases in the real-time scenario. And also when we know the storage concept, we should also familiar with what is a storage protection methodology. So we'll discuss the storage protection methodology, and we are finally in this session I'll just cover the vSphere storage overview and lab setup and all. I will just explain our demo lab setup. Why I'm again explaining demo lab setup is, in our real-time scenario storage, for the storage labs we need a original storage boxes. Suppose if you generally in the storages are like a three types of storages: DAS, NAS, and SAN. I repeat, DAS, NAS, and SAN. DAS means direct attached storage. It's like a, in our laptop we have a hard disk. It's already connected to. Just a second. I think someone is logging. Okay, so in our storage terminology, we have mainly the three types of storages: DAS, NAS, and SAN. DAS means a direct attached storage. The name itself says directly attached to storage. Even in our laptop also, our laptop motherboard directly connected to one local hard disk. Using that hard disk only, we can install the operating system and applications. Same way, NAS means network attached storage. That means from our laptop or from our server, we are accessing the storage over the network. Over the network means we can use any of the switch. Using switch, we are accessing the storage. That is called network attached storage. And SAN means storage area network, but storage area network is like a compared to NAS. Sandbox is a high configured storage box, but instead of normal network switches, for SAN switches, we required a fiber channel switches. Okay, it's not like a normal network switch. For sandboxes, we are using a different type of switches. That switch called fiber channel switches. Example, broket switches. Okay, so these concepts are same when comes to the physical storage, like a traditional storage, and also comes to the vSphere storage. Almost the same storage concept applicable in our virtualization. But the only thing is, in our virtualization, we need to understand the terminology. Suppose in our local system, we call it as a hard disk. These terms we use. But when comes to our VMware vSphere, the terminology is changed. For our virtual machine hard disk, what we can say? Virtual machine hard disk, we call it as virtual disk, or we can say .vmdk files. Okay, and also in the ESX level, we whatever the VMs where we are storing the VMs, that terminology we call it as data store. The name itself says we are storing the data. The data is nothing but our ESX host virtual machines. Okay, so let's start with the basic concepts now. Demo setup, why I'm highlighting the demo is, in our future further classes we are unable to do the actual SAN lab, but I will prepare some simulator kind of lab. Using that simulator lab, we can try to understand the our storage concepts. Okay, so that is the reason I'm just highlighting the demo lab setup, how we did it. But don't confuse, our demo lab storage configuration, everything is like a simulation only. It's not the real time setup. But in the real time setup, how they configured and all, I will explain theoretically. But the lab purpose will use some simulator softwares. Okay. Now let's start with the basic storage concepts. So storage is nothing but the action or method of storing something for future use. And storage is a location where data is held available in a digital format. Data stored on storage device or media, which can be local storage or external storage. Local storage means in our server we have a locally attached disk. That is nothing but a local storage. Suppose from instead of our server we are accessing the some external storage. That is nothing but a external storage. When comes to our home PCs, even our home laptop, we already have a local hard disk. If you want to keep your data, any of the additional data or personal images or any data, if you want to copy to external thing, we need to use a external hard disk. That is also considered as a external storage. So in this here I just collected few images from the Google. So suppose if you see the first image, it's like a SSD disks. SSD disks, it's are available in a different sizes. It's like a 2 TB and 3 TB. This is a HDD. HDD means hard disk drive, and SSD means solid state drive. And also if you open the hard disk, the inside is like this. This is the view for the normal SSD disks. And not only the hard disk, we also have some of the memory cards also. Memory card also one of the storage device. Normally we'll use for a cameras, or we can use for a mobile. And this is a normal home level hard disk types. Suppose in our server environment, why we need a storage means, for example, the physical hard disk max it's available for until 2 TB or 4 TB. If your production servers data every day we are using, multiple applications data we are storing, all the users, whoever the using the all the applications and all the users data we have to store in our server. But the data is keep on growing. If your data is more than 10 TB, or if your data is more than 20 TB, when your data is keep on growing, our local hard disk is not enough to keep all the data. So in order to address that situation, in our real-time scenario, we have a different type of storage boxes. Using these storage boxes, you can keep all your data in a external disks. It's the same like in our home PC also, we are storing some data on either a pen drive, or we can store on a external hard disk. Even external hard disk nowadays it's available for starting from five. You can use from 512 GB or one TB, 2 TB, and so on. So TB means terabyte. 1 TB equivalent to 1000 GB. Either you can use terabytes of external disk to store your home systems. But when it comes to the real-time scenario servers environment, it's the data is not only terabytes. If you compare in a large scale organization, data is more than terabytes. Or if it is reach more than 100 terabytes and all, it's reach a petabytes. Even to maintain all your petabytes of data, we need a high storage area network. Separate storage boxes are needed. Suppose in this diagram I put the storage array. This is nothing but a storage array. It looks like a server, but it have multiple SSD disks. All this, either you can use SSD disk or you can use a flash drive. Anything you can use, depends on the server model. Suppose I have below one storage array. When your storage array all the data is full, the only solution is you can add one more storage array to keep your data. Okay, so this is about the basic understanding of storage. Okay, now we'll observe the what is the purpose of storage. So storage mainly for to store all the project related application data. Every company, whatever the project they are doing, all the project related application data only we are storing in a storages. Even not only in a office environment, even in the home environment also, all your personal data. Personal data is nothing but like Word documents, Excels, and PPT, or any of the images. These are all our personal application data. These all applications data also we are copying into the any of the internal storage or external storage. And applications are loaded from storage to run in memory. Like suppose if I want to run the any of the Windows Word document, if you open the Word document, for example, I'm just Windows run and type the WinWord. I just open a WinWord. When you open the WinWord, if I want to type anything like any of the storage disk, if you want to write or anything, let's say, let me choose the any of the icons. For example, we'll choose the one of the storage icon. Normally the storage icons are represents like a, this is one of the storage icon. Let's say I just typed one icon. Even if I want to copy one more icon, let's copy and paste. We can copy the multiple storages icons also here. And even one more, whatever I'm doing now, I'm just taking the multiple storage volumes. I'm just taking the multiple copies. But in this scenario, whatever I typed here, these all currently it's running only on the primary storage. Primary storage is nothing but it's a memory, RAM only, random access memory. If you want to save permanently, this is only temporary. If I just close this one, it will directly close. Even if you want to save anything also, if you want to save it to your hard disk, then only it's going to the secondary storage, which is the our local hard disk. So for local hard disk means we need to save, but before saving, everything is stored on a RAM. It's a primary storage. Okay, the same point mentioned here. Applications are loaded from storage to run in a memory. Okay, but this application, Word application is it's opened from a our permanent storage local hard disk. And temporarily we can run in a memory anything. Again, if you want to save it in our local disk, you can just go to save as and you can save it to local. Okay, so and another point, application produce output or state as a result. Like it will provide any of the output. For example, I just given Microsoft Word, PowerPoint, and Excel. Even why we are using Microsoft application, PowerPoint, Word, and all to present anything. Even now I am presenting the slide using Microsoft PowerPoint. So application name Microsoft Office, I'm using the PPT application to present our today's discussion. So same like that. Not only MS Office, we can use some of the external applications like MSBI, Power BI. We can use the third-party applications, IBM DB2 database application, or ERP applications like uh, SAP. Any of the application we can use. Whenever we are start using the applications, there will be some end goal and end results we will get. And computer memory is volatile is nothing but it's kind of temporary storage. When system is shut down, the content is disappeared. But to maintain the application data, persistent is nothing but a permanent. Persistent storage is necessary given. Okay, So this is the main purpose of the storage. But within the storage, we have a in order to run the storages in the background, there are some protocols also in used. It's a similar like in our during the networking concepts, we discussed about the protocol. We discussed the protocol TCP/IP, SFTP, SMTP, and all. These are all the network related protocols. Similarly, even in the storage also, there are some storage related protocols. So we'll observe the protocols now. So local disk storage protocols. A protocol is the language that local disk storage uses to communicate with a device. So it's a kind of language only communicate from one device to another device, vice versa. So several commonly seen protocols are, suppose in our normal storage protocols, even when we creating the virtual machine, you can see multiple storage protocols. You already noticed SCSI, SAS, SATA. These and all will find when we creating the virtual machine. So SCSI full form is small computer system interface. Normally in our olden days, in our local system, hard disk is connected with these ports only, SCSI ports. This is like a uh, this is connected with a IDE cables, integrated drive electronics cable. After the SCSI, now we started using the latest hard disk, which is SATA, Serial Advanced Technology Attachment, and some are the SAS also. SAS also Serial Attached SCSI. So these are looks like a icon is instead of this many ports, we can see the icon looks like this. Okay, this is the SATA hard disk ports. And USB. USB means Universal Serial Bus. So normally our external hard disk looks like this. It will connect with a USB port only. This is also we used for the storage protocol purpose. This is a protocol names. And for a fiber channel, suppose from my local system or from my local server, if I want to access any remote storage, the protocol is fiber channel. So servers may need an adapter. For normally for our local system, we no need anything because we are hard disk is directly connected with using SATA cable. But for the servers may need an adapter to communicate with local storage. This adapter is known as host bus adapter. In short form, we call it as HBA. HBA means host bus adapter. The same host bus adapter is required for our ESXi host also, because ESXi also one of the server. To access from our ESXi server to any of the SAN storage, either your fiber channel SAN, we require a, in our storage level, we require a HBA card. But if you see this card icon, this icon, it looks like our network interface card, but it's not network interface. If you see the port number, port style, this port is not like a RJ45 port, it's a fiber channel ports. Okay, so HBA card looks like this. This is about the local disk storage protocols. Now we are going to observe what are all the storage types available in the real-time scenarios. There are three types of storage types available, and mainly suppose if you observe the storage types, why we need to discuss the storage type means all our applications need a certain type of storage to store the data. But in the real-time scenario, either in the traditional storage or in the virtualization, main storage types are only these three storage types. So first one is block storage, and second one is file storage, and third one is object storage. And this is also one of the interview questions. Most of the interviews, they will ask how many types of storages we have. You can remember to say this is the three types of storages we have: block storage, file storage, and object storage. And now we'll start observing what is the differences between each storage. Suppose the first one, storage type, we can observe these points. Data stored in fixed size block in a fixed arrangement, ideal for enterprise apps and database. Even in our local laptop or a home PC or server, we have a one hard disk. It's kind of fixed size block only, and mainly we can use for a applications and database storing purpose. Even in your home PC, we are using a multiple applications like MS Office application, PDF, Adobe PDF, and also we can use some external applications. Even if you want to play any of the videos, we are using VLC player and some external players. So these are all our application. But when it comes to Office, we can call it as a enterprise applications. Even our ESXi is also enterprise application, enterprise operating system. So we need to run, in order to run our ESXi host on server, we need a local hard disk first to install the ESX operating system. Either we can run the ESX on a local hard disk or you can run on a SAN also. We have two facilities available. Either we can boot the ESX from local hard disk or boot from the SAN. Any method we can do. But these two are considered as a block storage. And the another point in the storage block storage is fully integrated with servers. These all fully integrated only. It's a directly connected only, and a specific location on memory or disk. Normally, the whenever we want to store the data, anything in the block storage, first it will store on memory and followed by it will store on a disk. Memory is nothing but a primary storage, and disk is nothing but a secondary storage. And primary storage memory is temporary, and the disk is like a persistent memory. It's a permanently it will store on the hard disk until we delete. And now we can observe the file storage now. Under the file storage, the name itself says file storage. Whatever the files we have in our system, if you want to share that file, that is nothing but a file storage. It's only files and folders only we can share. But in order to share the files and folders, the backend, the main important protocol name is NFS, and the storage we call it as a NAS. Let's understand the first point. Data stored as files in hierarchically nested folders, ideally for active working documents. Suppose in our project, we are working for some outsourcing project. Let's say HPE printers outsourcing project. If you want to know about all the printers information, there is some prescribed handbook for it consists of all the printers information. That document, instead of copying the same file on all the systems, we can copy into the one centralized system. That same common document we can share it to among the team members. So that is also one working document. Not only the working document, any of the project related documents, if you want to share it to all the team members, the only the best option is you can copy on one of the centralized server and make that file and folder to share it to the whoever the persons required the access. You can just allow the permission to specific users. And fully managed, this is also it's a fully managed by system admin storage administrators and network attached storage, and specific folder in fixed logical order. So which folder you want to share, you can share it. Suppose in our local system, if you want to check anything, just let's say C drive, if I want to check anything, let's say temp, anything, if you want to go to the C drive temp, and any folder you want to share, just right click here and properties, and you can share the data. Okay, like that we can do the sharing. And object storage, most of the time object storage we used in the cloud environment. The best example for object storage is Dropbox or OneDrive, Google Drive. These are all the object storages. Data stored as objects in scalable buckets. So that's why I put the icon as a bucket, scalable bucket, ideal for unstructured big data analytics and archiving. Archiving is nothing but all the previous data, old data we consist as archive data. So if you want to store your old past data in any of the storage block, file or object, the most preferable storage is object storage. And for any application, store any type and any amount of data for any duration and retrieve it as often as needed. And flexible container size, no platform dependency. No platform dependency means, suppose in this object storage there is no file system format or specifically no OS dependent. Whenever you want to store, you can just connect to the object storage URL. It's like a HTTP browser or REST API browser. You can connect to the browser and upload your data to the object storage. And let's verify the examples for storage types. The examples are pen drive. Pen drive also one of the block storage, hard disk, and hard disk also we have different types of hard disk, HDD, SDD, solid state drive, and we also have latest one flash drives. Even in the nowadays public cloud also they started releasing the specific storage types. I given one example for Amazon. Amazon is the most popular vendor for public cloud. So Amazon is releasing the one of the block storage type is EC2 instant store. EC2 means elastic compute cloud. For example, in our ESXi host, we are our virtual machine, we call it as VM, virtual machine. But when comes to the public cloud, Amazon, they call the virtual machine name as EC2 instance. EC2 instance means it's a virtual machine only, but they put the name as a EC2 instance. EC2 stands for Elastic Compute Cloud Instance. So to store the Amazon virtual machines, we need a block storage. And also there is a Amazon EBS, that is also Elastic Block Storage. That is also, the name itself says it's a block storage. This EBS and EC2 volumes we can use to store the virtual machines. And coming to the file storage is mainly for a sharing the files and folders, and files and folders is like a unstructured data. There is no structure, unstructured data only we are giving the share access. Even if you see the icon, it's like a normal folder we are giving the share access. And Amazon also, public cloud also having the one of the file storage feature, that is EFS, Elastic File System. And object storage, there are plenty of examples. I just given a 3 examples here. Dropbox is also a object storage. Anyone, if you register, sign up for your Dropbox, they will provide a minimally 15 GB free with the initial sign up, and later you can increase whatever size you want, that will be a chargeable. And even Amazon S3, Amazon Glacier, Amazon S3 Glacier also considered as a object storage. Okay, so S3 means simple storage service. Now, same like our local storage, whatever we have the protocols. Similarly, in our storage types also, each storage type we have a protocols. Let's observe the protocol. Protocol is nothing but a storage is consumed by a protocol. We are consuming the storage using the protocol only. So in our block storage, we have multiple protocols. Let's observe the one by one. First one is FC. FC means fiber channel. FCOE. FCOE means fiber channel over Ethernet. And another one is SCSI. SCSI means small computer system interface. iSCSI. iSCSI also a internet a small computer system interface. This is also one protocol. And SATA. These are all the block storage protocols. When comes to the file storage, we have the protocol. We can access the file storage using the either IP address we can access. So TCP IP also considered as a protocol, and NFS, network file share. And we also use the SMB, server message block, and CIFS. CIFS means common internet file system. But in general, for most of the Linux operating system, will use the file share protocol is NFS, and for the Windows operating system, it uses a CIFS, common internet file system. And comes to the object storage. In object storage, most of the time we can access the object storage using the URL only. URL means HTTP, HTTPS, TCP/IP, and the representation state transfer. REST also we can use. Normally, represent state transfer we can use like a REST API. Using REST API also we can access our object storage, whether it is in any of the public cloud. Public cloud, generally most common public clouds are Amazon, Azure, and Google GCP, Google Cloud Platform. These three are the most popular, and nowadays so many third-party vendors also trying to reach the. There is a competition between the top three vendors. Okay, but most popular public cloud vendors are, I repeat, Amazon, Azure. It's a Microsoft Azure only, Azure Cloud, and Google Cloud. Google Cloud is GCP, Google Cloud Platform. So if you want to access the public cloud object storage, we need to use a REST API or SOAP protocol. The SOAP means Simple Object Access Protocol. It's the name itself. It says object access. Object access means object accessing, object storage accessing only. Okay. And now interface. So what is our main interface to connect to block storage? So as we discuss, our local system, either server or laptop, operating system is our main interface to access the block storage. And DAS. DAS means direct attached storage. And for if your storage is very huge storage, DAS is not supported. We should go for a SAN. SAN means storage area network. And file storage, if you want to access your file storage system, the main interface is end users only. Any of either one user or group of users will try to access the file storage. And object storage, normally object storage, how we can access is we can access through APIs only. API program. API means application program interface. And now we'll observe the performance in a block storage. Block storage, normally the performance is high because our disk is connected to directly to motherboard. So it's a very high performance. That means performance always in the better only. There is no issues on the performance wise. When comes to file storage, sometimes there is a chance of network lacking. So we can consider this as a medium. But comes to the object storage, performance is low. If you want to access the small files, it will be faster. But if you want to try to access the bulk data, the object storage performance is low performance. And storage location. Normally the bulk storage where we can utilize is the location for the block storage is on premises. On premises means within the office environment, and also we can use for a private cloud environment. Private cloud means which is dedicated for only one organization. That is nothing but a private cloud. And that means whenever we are using a dedicated infrastructure, that is nothing but a private cloud. And file storage, for file storage also we can use on normally on a on premises and private cloud. When comes to object storage, it's a dedicated for either you can use in your on premises, you can use for private cloud, public cloud, and hybrid cloud. On premises means even in our home systems also we can use either Google Drive, or we can use the Dropbox, we can use OneDrive. These are all like a object storage anywhere we can use. And not only in our home PCs, and even in the office on premises environment, private cloud, public cloud. If you are using the both private and public cloud, that is nothing but a hybrid cloud. Okay. So this is about the object storage actual usage locations. Okay. Now we are going to observe the use cases for these three storages. What is the main use cases? So use cases are, when comes to the block storage, the use case is low latency, best for a structured data. Structured data means any of the database servers we can use, and unstructured data, not only for database, we can also use to store your application files and folders. Wherever you want, you can copy. That is nothing but a unstructured data. And the disks for virtual machines. Even this block storage is supported for a virtual machines as well. Virtual machines supported file system is VMFS volume. VMFS stands for virtual machine file system. And block storage we can also use for share the read-only data across virtual machines. Across virtual machines, suppose in our local system data, normally this local system data, if we want to provide the access to another system, we can share that folder and provide the access. Without share, we cannot provide the access to the other remote system. That is only the read-only data across virtual machines. If you want to provide the access, that again it comes under a file storage. We are sharing that folder or file and providing the access to another user. And the storage for databases, frequently changing data. Normally in the block storage, frequently changing the data. Even in our local laptop, daily we are opening some files, doing some modifications and saving. That is nothing but a frequently changing data. And comes to the file storage use cases. File storage normally it's a good performance, and the file sharing data and media processing. Suppose your company is telecasting some annual report. That annual report web if they are projecting on a some video or any of the webinar, that media also we can process it for entire office environment. So that is nothing but a media processing, also one of the file storage. And application migrations. Application migration means, so for example, we'll talk about two scenarios. One is home scenario, another one is office environment. Suppose even in our home environment, if I want to format my laptop, what we can do, we can take the backup of our laptop to another system or another hard disk, and then we'll format. Similarly, in our office environments also, if you want to migrate your production, if you want to migrate or if you want to upgrade your database, or if you want to change the database from one version to another version, for example, if you want to change your database migration from MariaDB to InfluxDB, both are two different databases. During that application migration scenario, first we can copy all the your data to the our file storage, like our SharePoint portal or any of the file server. When you copy to the file server, our data is safe, and then you can start migrating from MariaDB to InfluxDB. I'm giving one example. So similarly, even if you want to migrate your data from Windows SQL to PostgreSQL, two different database applications. During that scenario also, for a safety purpose, we need to take the backup of our data, or you can copy your important files and data to the your file server. That is the reason, that is also one of the use case. File storage is application migration scenario we can use. And another one, web content management. Suppose you have a one website. For all your website data, also you can share it in a file server. And unstructured data file backup. Normally file storage have a, you can copy any kind of files and all, and no need to follow the hierarchy. It's a unstructured data only. And also a file backup. Even all your team employees data you want to copy and take the backup also, you can take the backup to the file server. So that's why I mentioned as a file backup. And object storage also, there are few use cases like easy scaling with no limits. That means for object steering there is no limitation. For example, in our block storage, let's say my hard disk size is 1 TB. Whenever your 1 TB is full, there if you want to add increase the size, there is no there is a limitation. We cannot increase the physical hard disk. The only option is either you can insert the new hard disk or you can take some data to the external hard disk. Even in the office environment also, servers also, once your storage is full, the only option, we need to add a additional storage, or you can copy the data to any of the external storage. Okay, but when comes to object storage, easy scaling with no limits. It's a kind of object only. It's simple to, you can add on easily. It's because it's a object storage, and accessible across LAN, local area network, and wide area network. And streaming videos, all the streaming videos also stored in a object storage only. And images, documents, backups, and regulatory archives. Regulatory archive means our past week data, past month data, past year data. These all past data we consider as a archive. All the archive data also recommend to store in a object storage, because the object storage cost is very low. And the websites and configuration data, even the disaster recovery site also, if you have a primary site in some location and your secondary location, instead of uh, investing on our physical location, you can make our public cloud as a disaster recovery site. During that time, all our on premises data, we need to take the backup and store it in a object storage. So object storage also used for a disaster recovery scenarios. And relative static file data as cloud storage. Okay, and proximity means accessibility, how we can access the block storages. It's mainly accessible from dedicated network fiber channel is nothing but a normal fiber cables. A fiber channel cable we can use to access from server to FCSAN. And the speed, normal recommended speeds, minimum speed is 1 Gbps, and we can start ideal speed from 10 Gbps, 20 Gbps speed, 25 Gbps, and so on. Okay, and the file storage also, in our office environment, recommended speed start from 10 GB. And object storage, how we can access the accessibility is mainly through internet only. It won't access normally intranet site, only with the internet sites only it will work. And the type of update, how we can update our storages, how we can update is normally for local hard disk or local sandboxes, it supports to do in place updates. It's a similar like, suppose my Windows file system is still running with a FAT16 file system or FAT32 file system. I want to update my file system from FAT to NTFS, you can do it on in place update. And similarly, in file storage also we can do in place updates. NFS version, suppose my NFS version is 3, I want to update my NFS version from 3 to NFS 4.1. In place update is possible. When comes to the object storage, it's not like a no in place update support. We have to do create a new object versions only. There is no in place update option. Okay, and now come to the scalability. Scalability means capacity to be changed in size. Even if you want to change the size and all, it's normally it's not possible. So that's why we mention as low scalability. And file storage is high. That means we can create multiple folders. We can share it whenever is necessary. We can easy to scale up or scale down. And even the object storage also, we have facility to do scale up and scale down. And come to the cost. How about our storage cost and cost? Block storage cost is expensive. That means it's a very high, and the file storage also high. And comes to the objective storage, it's a low cost because it's a public cloud storage only. And amount of data. Normally, the what is the preference to use block storage? If your data is less than 500 TB, okay to go with the block storage. That means you can buy a internal sandboxes or NAS boxes for the block storage. But file storage also, if it is your data is less than 100 TB or 100 to 500 TB, the recommendation is you can go, if you in order to expand, we can use a NAS boxes. NAS means network attached storage boxes. But object storage, if your data is more than 500 TB, that scenario, best way is instead of investing on a high expensive storage, you can maintain the last 3 months or last 1 year data on premises. All your previous old previous past 5 years data or past 10 years data, instead of maintaining in our local storage, you can just move it to the object storage because cost is low and we can maintain the older data in a object storage only. So that means in basic terminology, all the storage purpose is common to store our application data, files and folders. And also if you have any media files like MP3, video files, images, everything, all the storages are same. But only thing is depends on our requirement, we can go with the specific storages. If you observe the cost block storage, it's expensive. So normally the most production servers data, we can go with a sandbox only. Suppose if you have a test machines, for test machines, instead of investing on a block storage, we will prefer to use a NAS box. It's a file storage, NFS file storage only. Suppose if you instead of a test system and production system, we also have a old data. Old data, last 5 years data or last 2 years data, last 3 years data. This data also no need to maintain in the high configuration sandbox. During that scenario, in order to reduce your infrastructure cost in storage perspective, you can recommend to choose the object storage because it will helpful to save our cost as well as the old data safely stored on a cloud environment. Either you can store on a private cloud or public cloud. It depends on the customer's requirement. Okay, some customers they store in a private cloud, some customers they go with a public cloud. Based on my experience, what I noticed is most of the banks and bank and government agencies they recommend to use a private cloud because of data sensitivity. But other third party companies like any of the solar industries or any kind of third party industries, they will go for a public cloud because the most critical data they maintain in a on premises and private cloud, and the less critical data they move it to the public cloud. Okay, that is a normal use cases. Okay, so until now we discussed about what is a basic storage purpose and storage types. We observed there are three storage types: block storage, file storage and object storage. And we also observed the main use cases. But we are familiar for the use cases. Now we are going to observe the storage protection. How we going to protect the storage? Okay, so I will give you the some basic protection mechanism. Okay, this mechanism is applicable for traditional storage as well as our VMware vSphere environment storage also. Still the concept is same. Okay, so let's observe the storage protection. Do you have any questions before we move on to the storage protection? Do you have any questions on storage types and use cases? Okay, if no questions, I'll just move on to the storage protection. Excuse me. In storage protection, see, I mentioned the first point. The purpose of block, file, object storage are the same. Always it's the same. Uh, Technically, it's a three types of storage, but the purpose is always to store our application data and files and folders only. So depends on our requirement, we can choose the different types of storages. It's the same like even when we want to buy a laptop, there are plenty of vendors available in the market. You can buy HP laptop, Dell, IBM, Dell, any vendor we can choose. It depends on our budget and requirement. We can choose the best laptop. Same way in the storage also. We have a three types of storages. Depends on the customer requirement. If the customer recommend for a high expensive also, they are okay to manage the budget, will go with a SAN. Suppose their budget is not enough, they will go with a NAS storage. Okay. So, and also at the end of the day, the storage protection means the main key point is storage availability. How effectively we are maintaining the storage and also the data protection. When comes to the data protection, single storage devices like SSDs are subjected to failure. Suppose in our laptop or our server, we have a one ssd disk. That ssd disk, there is a chances of ssd disk failure. So the to avoid that failure scenario, the only thing is data redundancy is a requirement. Data redundancy means in order to maintain the SSD disk securely, instead of using the one SSD hard disk in our real-time scenario, every server must have a minimally two SSD disk in a local storage. If you have a two SSD disk, this two SSD disk always mirror the data from disk 1 to disk 2. So in case of any one disk failure, there will be no impact to the production. Still our production is alive. Okay, so whatever the hard disk is failed, immediately you can replace the faulty hard disk with respective vendor. Suppose if your server is HP server, you can contact the HP vendor. If your server is a IBM, contact the IBM vendor for the faulty hard disk. You can just raise a support request with your server serial number so that they will come and replace the faulty hard disk. But our responsibility as a VMware engineer, even your ESX server local hard disk is failed, our main responsibility is we need to identify our server serial number. With the serial number, you can raise a request to the respective vendor. Once you raise the request to the respective vendor, the vendor will diagnose the hard disk status and they will confirm to replace the faulty hard disk. That is the usual process in office environments. And protection methodologies, there are plenty of methodologies. I just trying to give you main important methodologies here. The first one is disk mirroring. Just now we discussed disk mirroring. Disk mirroring is nothing but a copying data from one disk to another disk, and I given the definition below. uh, let's observe the one more protection methodology. Protection methodology, another important is RAID. RAID means redundant array of independent disk. So in the RAID system, we have a multiple RAID levels like RAID 0, RAID 1, RAID 2, RAID 3 until we have a RAID 10. We cannot say RAID 10. We call it as RAID 10. We have the RAID levels. But today I will try to explain you the two RAID levels, RAID 0 and RAID 1. But whenever it is necessary, when we are discussing the storage concept, I will explain in detail in the future sessions. Okay. But try to understand what is importance of RAID. And disk mirroring. Disk mirroring means, as I mentioned, to make an exact copy of data from one storage drive to another storage drive in real time. This serves to prevent data loss in the event of a hardware failure. Why we are copying to another storage is, in the case of hardware failure, there will be no impact to your production. And this is also known as RAID 1. Disk mirroring, another name is RAID 1. Okay, so now we're going to observe what is importance of RAID. I will show you in the next slide what is the purpose of RAID. So this is a software storage protection methodology. So RAID full form is redundant array of independent disks. Okay, so storage that is made up of multiple hard drives. The same data is stored across different disks. Okay, the method by which is data is stored is classified by RAID levels. So RAID levels, we have RAID 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. In the most of the real-time scenario, the most commonly used RAIDs are RAID 1, RAID 5 and RAID 10. These three are the most popular RAID levels. Okay, the remaining RAID levels, very rare cases we use. Most popular RAID cases are RAID 1, RAID 5, RAID 10. Okay, so in this session, I'm trying to explain the RAID 0 and RAID 1, how it will work. Suppose RAID 0, try to understand the RAID 0. RAID 0 means striping with no fault tolerance or no redundancy, designed for speed. This is mainly to designed for a speed. Suppose in the right side diagram, if you observe RAID 0, I'm trying to explain with the hard disk. Let's say here we have a 0 to 9. 0 to 9 means totally 10 hard disks we have. But the data is not copied in a sequence. 5 hard disks copied with a half 50% of data, 5 hard disks copied with a 50% of data. Let's say my data is 0 to 9 numbers, all the data I want to copy. But how it is copied is 0 is copied on one disk, 1 is copied on here, 2 is copied on here. Let's say these 5 disks are one set, these 5 disks are one set. If your one set is down, that means still with our data, 50% of data is available. That means the RAID 0 is mainly for designed for a speed writing purpose only. But when you compare in case of data, any of the hard disk is failed, some 50% of data is loss. So it's that is the reason RAID 0 is not recommended in the real-time scenario. Now observe the RAID 1. What is the RAID 1 importance? Importance is mirroring with no striping. So striping, I will just explain in the below. So in the RAID 1, there is no striping, only mirroring, designed for reliability. Okay, it's a mainly reliable method for RAID 1. If you use the RAID 1 diagram, see we have again 10 hard disks, but those 10 hard disks, how the data is stored is 0 to 4, 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. Sorry, there is a typo. Even the whatever the data on the disk 1, the same data will be on disk 2. Here also 4. Okay, so the entire data is duplicated here. So even though our hard disk is down, there will be no impact to our production. Okay, so now tell me which is the best method to use in the office environment. Let's say in our ESXi server, I have a 2 SSD. I'm planning to configure a RAID before installing the ESX operating system. So will you prefer to use RAID 0 or RAID 1?
Right one.
So RAID 1 only, recommended one. Okay, and now try to understand the stripe. What is nothing but a stripe? Stripe means to divide a piece of data equally sized units. So even if you observe the RAID 0, we have a 1 to 9, 10 bits of data. All the 10 bits, how it's equally divided. Here one bit, here one bit, here one bit, here one bit. The same point mentioned here. Stripe is nothing but here to divide a piece of data into equally sized units, which are then spread across multiple storage devices. Okay, no copies of data are made here. No copies actually. It's just striping the data. This is often referred as a RAID 0. Okay, and RAID 1 means the main terminology for RAID 1 is disk mirroring, and RAID 0 terminology is disk striping. Okay. And there are other RAID formats that utilize it for both striping and mirroring. For example, if you want to verify the RAID 5, RAID 5 is nothing but a it will copy the data with striping with parity. Okay, like that. Suppose RAID 10. RAID 10 means one is nothing but a mirroring. RAID 10 means it's a mirroring plus striping. If you have a 4 hard disk, the if I just put the beside the RAID 10 means just combine these two diagrams, it will become a RAID 10. How it will copy means if your data is 0 to 9, 10 bits of data, the first bits completely it will mirrored into the RAID 1, and similarly 0 means it will stripe. So the minimum requirement to configure RAID 10 is minimum requirement is 4 hard disk. Okay, so first 2 hard disk it will mirror, second 2 hard disk is stripe. If you configure RAID 10, it be a very high-end redundant array of inexpensive disk. The purpose of RAID 10 is even though 2 hard disk fail, there will be no impact to the production. But in the RAID 1, at a time 2 hard disk fail, but very rare case 2 hard disk failure. But if you at a time 2 hard disk fail, RAID 1 also no use. So that is the reason if your company data is very critical, they may go to configure the instead of RAID 1, they may go for a high level RAIDs like RAID 5 they may use or RAID 10 they may use for data protection purpose. Clear? So just quickly go back and verify. So just now we discussed about the what is the storage and storage purpose, and we observe the local disk protocols and storage types. This is the important point: block storage, file storage, and object storage. And use cases we observed and storage protection, and we observe the RAID also. Okay, now it's the time to start our vSphere storage. vSphere storage still use the same traditional storage boxes, but when comes to the ESX and vCenter environment, only the terminology is different, concept is same. In our normal disk environment, we call it as disk, but when comes to VMware ESX, we call it as a vDisk. Okay, that is only difference. Even in the storage environment, the bulk data we call it as a LUN, logical unit number, but when comes to the ESX level, we call it as a data store. The same LUN when we are using in a ESX level, the naming convention will change, but the concept is still the same. Okay, so in this session, I'm trying to give the some basic overview of vSphere storage, and next session onwards, I will try to explain one by one. This is the vSphere storage overview. So the same concept. Today's session, I will try to explain at least one storage, local disk. If time permits, I will show you the NAS, or else NAS, the remaining storages will continue in the next sessions. Okay, so vSphere storage, try to understand the vSphere storage now. Even if you see the diagram first, it's easy to understand the concept. If you see the first one, VMware ESXi host, we know how to build the ESXi host. So we have a three ESXi hosts here, three physical servers first. On top of the physical server, we install a VMware ESX. VMware ESX. The purpose of ESX is it allows to create a multiple virtual machine. So each host we have a 6 virtual machine. And even why we are creating a virtual machine is to install the guest operating system and project related applications. So there are multiple applications are running on the virtual machines. So for this, to store all this virtual machine data, we need a storage. So same like our physical storage types, even in the VMware also, it's supported for two storage types. One is VMware vSphere VMFS. VMFS means virtual machine file system, and NFS. So you can use the any type of storage in the real-time scenario. It's subjected to be customer requirement and customer decision only. But as a VMware engineer, we must learn all the concepts. Okay, suppose if you join any organization, they may not use all the storages. They may use at least one or two storages, minimally one, and max they may use two. If your organization have a multiple branches, there is a chances of using all types of storages. Okay, so under the VMFS storage, we have this is icon for data store icon. Within this data stores, again we have a storage technology, multiple storage technologies. We can use local disks, we can use fiber channel, we can use fiber channel over Ethernet. Okay, and iSCSI SAN. These are all the SAN types, either FC SAN, FCOE SAN, or iSCSI SAN, or else you can use a NAS storage also, network attached storage. Okay, the same one a little bit elaborated here. Okay, try to understand the points one by one. Data stores are logical container that hide specifics of the each storage device and provide a uniform model for storing the virtual machine files. So here mainly for storing the virtual machine files. So can you tell me what is a virtual machine disk file? What is the extension for a virtual machine disk file?
VMDK.
It's a VMDK. Okay, and now both local or shared storage, anything are a core requirement for full utilization of ESXi feature. So ESXi feature, why we mentioned local and shared storage is to install the ESX operating system. The best practice is install ESX on a local storage, and to store the virtual machine, recommendation is you can store on a VMFS or NFS. But this both VMFS and NFS are considered as a shared storage. Shared storage means this data store is shared between all the virtual machines and also shared between the ESXi host. Okay, that is nothing but a shared storage. And now many kinds of storage can be used with vSphere. So vSphere is supported for many storages. Not only this four, I also given some additional one. Local disk we know, and fiber channel SAN. This is also one type of storage, and iSCSI SAN. But only difference in these two SANs is FC SAN means our protocol mainly used is FC protocol. iSCSI SAN means it's a used protocol is iSCSI. That is only the main difference. And another difference in fiber channel SAN and iSCSI SAN is fiber channel SAN means it uses a fiber cable and also it require a fiber channel switches. Okay, when comes to iSCSI SAN, iSCSI SAN doesn't require any fiber channel switch. It uses a normal IP network switch. Normal switch also it used. That's why the protocol also Internet SCSI protocol only. Okay, and the NAS also required a normal switch only. It's not doesn't require a fiber channel switch. Normally, fiber channel switch cost is very high cost compared to normal network switch. Okay, and NAS means network attached storage. So this is the four I mentioned here. Okay, all the types are mentioned here. FCOE also there is a one special category. The protocol only different, but the concept is same. FCOE means fiber channel over Ethernet. Okay, and in our virtualization there is a new concept called virtual SAN. So along with these storages we should also going to learn virtual SAN. In short form we call it as a vSAN. Okay, so this is an important concept. Nowadays most of the interviews also they're asking few questions, and even when you're attending for a VMware certified professional exam you may get a few questions related to the vSAN also. And vSAN, and also there is another concept which is a virtual volumes. In short form we call it as vVols. Okay, vVols is nothing but a virtual volumes. And there are generally formatted either. So as I mentioned, ESX server supported mainly two format file systems. Either you can format the file system with VMFS or you can format with NFS. NFS is file system we can format only in a NAS storage box, and the rest of other storage boxes file system type is VMFS. VMFS full form is virtual machine file system. So today I will try to show you how to add the local storage to ESX. Okay, and if time permits, I will show NAS, or else NAS we can continue on a tomorrow session. Okay, and before going to start our lab session, is there any questions on today discussion points? Is it clear or
Yes, sir.
okay? So now let's move on to our demo lab setup. Just trying to explain our lab setup one more time, because from our next class onwards most of the time we connect to vCenter and start, but how we configure the networking and storage and all I'm just trying to explain here. So so normally I'm using one personal laptop. From personal laptop, as we know, we install the VMware workstation. This is the icon for VMware workstation. When we install the VMware workstation in our local system, it will create a virtual network, and we are using the VMnet 0. This VMnet 0 we are using like a virtual switch. Okay, but it's not really a virtual switch. We are using VMnet 0 as a virtual switch. Okay, on top of our workstation, we created a four virtual machines, and one virtual machine is AD01. We are using for a Active Directory and DNS purposes, and another virtual machine we created for ESX. But in our test lab, we created on VM. But in the real-time scenario, remember that ESX, in order to install the ESX server, we need to use a physical servers, or you can use any type of server, any server form factor. Like you can use tower server, you can use the rack mount server, or you can use a blade servers like HPE Synergy servers also we can use to install the ESX box. But our testing purpose only we are installing on VM. But in the real time scenario, this is not the case. We need to install directly on a hardware. That's why we call it as ESXi is a bare metal virtualization software. And we also created another ESX, ESXi02, two ESX we created. And to manage this ESX environment to ESX2 ESX boxes, we created a virtual center server, and virtual center server name I given as a VCSA01. VCSA full form we know, vCenter Server Appliance. Okay, and IP addresses also I just highlighted. Our AD server IP is 70 and ESX IP is 71, ends with 71, and ESX2 last octant is 72, and vCenter's last octant is 79. Okay, and the same information I just updated in our spreadsheet also. So spreadsheet we can start doing the tracking. Whenever we do any modification we can update. Why I'm updating this spreadsheet is even you can just start practicing this even in the real time scenario. Every organization based on their inventory size. Suppose you have 100 virtual machines and 10 or 20 ESX boxes. To identify all the information, the best way is you can maintain the one spreadsheet with all your inventory details. So I just prepared the some inventory list here. If you observe the first three one, these first three are my lab workstation, three systems, and our virtual machines. I just mentioned the server type as virtual machine. So virtual machine, our AD server, I given the IP address is 70. If you see the IP address here, it is a 70 IP address, and 71, and I created another ESX also. So 71, 72, 73. So I just prepared for our further labs. Three ESX are ready now. So three ESX, one AD server, and we have some free available IPs. These IPs we may use for any of the test missions, and I also reserved the three IPs for vMotion network. Okay, this one also we can prepare in the future. Okay, so whatever the IPs are free, I just make it as a available IP. Later we can use. And to segregate our all the virtual machine storage, for example, my Windows 22 AD DNS server, how we given our lab CPU and memory is 2 CPU, 2 GB memory, and I given the size as 200 GB. Okay, and this is the IP address, and the right side I just written as all our systems domain we configured as a demolab.com, and subnet mask is common for all virtual machines. Default gateway also common. It ends with 1, and the DNS IP is equivalent to our AD server IP. Okay, so these details I written separately. Right side reason is this the gateway subnet mask DNS is common for all virtual machines. Okay, only the IPs are it will change, and the DNS gateway default mask subnet mask is common. Okay, and if you see in our local lab system itself, how much storage we are using now, if I select the disk sizes, we are already using a 260 GB. And even the local hard disk, I configured as a 2 terabyte. 2000 GB means it's a 2 terabyte. Suppose if your size is keep on increasing, even our local disk is not enough, we need to buy a external storage. Suppose if you want to buy the external storage, let's connect to our lab system. I'm connecting to 100, one of our workstation, lab workstation. Lab workstation IP is 100, 10.100. So I'm connecting to 10.100 lab workstation. Suppose in our lab workstation, just in the Google, if you type the NAS storage, we'll just observe how the NAS storage looks like. So if we go to the images, see, NAS storages looks like this, but in our test lab, at present, I do not have this NAS boxes and all, but I will try to explain how the NAS is configured. Okay, even I will try to show you using the simulation method, but NAS boxes looks like this. Not only this kind of small size, even there is a big size of like NAS boxes. Even HPE also have there are some NAS boxes. NetApp, Nimble, there are so many storage box models. For example, I just typed in the Google HP NAS. HP NAS also we have some HP storage easy storage, HP store easy storage. This is one type of NAS. So like this, we can use in the real time scenario. Okay, but I will show you in the next lab how we configure the NAS in our test lab. Okay, but whatever we are doing in the lab, the same concept applicable in the production also. Okay, and even the sandbox also, if you want to see, just type HPE SAN. If you type the SAN, how the HP SAN looks like is like this. It consists of n number of disks. Even one storage array is full, you can buy another storage array. Okay, there are multiple storages. Okay, even the SAN switches also, you can just type in the Google SAN switches. You will find the SAN switches how it looks like. It looks like a normal network switch, but if you see the port is not a RJ45 port, it's a fiber channel port. Ports are different ports. Okay, if you see here, it is showing the SAN switch for HPE Synergy. Even if your requirement is more, you can buy additional switches. Okay, but normally in the real-time scenario, all the storage configurations are taken care by storage team. But as a VMware vSphere engineer, we should also learn what is the actual concept they are doing in the backend. Okay, we should be aware of what they are doing the changes. If you know the storage knowledge, it will be a additional value added for your resume also. Okay, see, this is a nimble storage, how it looks like and all. Okay, later you can just explore any model you want to check. You can just search in the Google, go to the images, you will find how the switches and the sandboxes looks like. Okay, so let me close this browser, and this is the lab. So now I'm trying to log in Center server IP now. And also I will show you our workstation, how I configured. See, we configured the AD01, ESX01, ESX02, ESX03, and VCSA. If I select the AD, see in the right side, you can see the AD server. and ESX1 is ready, ESX2 also ready, and ESX3 also ready. And all the ESXs, I just given the memory as 4 CPUs and 16 GB memory, and hard disk I just given only 20 GB only. But there is no local storage to create the virtual machines. So today's lab, I will show you how to add the local storage. Okay, so local storage we are going to create. Let me connect to the system, and even the vCenter server also it's up and running. And even in the vCenter workstation level, if you want to create a folder in the not only in the vCenter, even the workstation also have a feature to create a folders. If you want to create folder, you can create folder and set it. Suppose the folder name is let's say vSphere 7.x lab, demo lab. I just created the folder. If you want to move all the VM under the folder, you can just move it. Later, if you are practicing any of the other concept like NSXT or Tenju, you can create those specific folders. So those related VMs we can configure separately, like NSXT one folder and also the Tanju one folder. And if you are configuring a vRA, we can create a one folder. Like this, we can also segregate. Under vRA folder, you can create the new virtual machine and all the vRA related VMs under this folder. Like this, we can segregate. This segregation option same in the vCenter and workstation. Okay, folder is like a just a hierarchy only. So now which we can log into the vCenter server first. So it's a 79. Open the browser and type our vCenter server IP address. Okay, now click on launch vSphere client. Okay, so what is the default login for vCenter server? Is it root or administrator for vSphere client?
Administrator.
Yeah, administrator at the rate vsphere.local. So we just log into the vCenter. It's a fresh login. Present, there is nothing was there. So what is the first step we have to do when we log into the vCenter? The first step is we have to create a data center. Okay, so select our vCenter name. You see it is showing as VCSA 0.01.demolab.com. Right click. The first step is we need to create a data center. So let's say our data center name is DemoLab Data Center. Or you can just keep the same name. Let's say I'm just mentioning as Data Center 01. If you want to put any specific name also we can put. For example, Production Data Center 1. Click on OK. So naming is like it depends on customer. You can change anytime also, just right click rename. So we created the data center. This is the icon for data center. There is no host. All the host, virtual machine, cluster, data store, everything is blank. So I'm going to add the 3 hosts one by one. In our previous lab, we observed that we added the host with the IP address. So today I'm trying to show you how we can add with a name. Okay, so same like IP address, we can try to enter the name. But remember that if you want to add with the ESXi host name, our all the DNS records should be updated in our AD server. Suppose just quickly log into AD and verify the whether DNS records are created or not. So in our DNS server, just close the browser. Yeah, DNS is already open. Okay, when we log into the DNS server, go to our demolab.com. In the right side, you can see all our records are created. Our Active Directory record, ESX1 record, ESX2, ESX3. Host records are created. Even the VCSA host record also created. Same like host record, we also have a reverse lookup zone and verify the pointer records. See all the pointer records also created. 70, 71, 72, 73, and vCenter IP I given as a 79. Okay, all IPs are created. Now it's the time to configure the vCenter hostname. So let's enter our ESXi hostname. ESXi hostname is esxi01.demolab.com. So you can type this way. Let me copy this name. Now press next. Okay. Now username and password. Our ESX host name is username is root and enter the password. Now click on next. Security alert. We need to accept our certificate. So just click on yes. And all this is the summary host summary information host name, and we created this host on a one of the virtual machine. That's why it is showing vendor name is VMware. Okay, and version is ESXi 7.update 3. Now virtual machine blank, that means no virtual machines are created. Click on next. And assign license, we are just using a evaluation license. And lockdown mode, just keep it disabled. Click on next. VM location, same data center. Click on next. So this is the ready to complete summary tab. So now click on finish. So in the recent task, we can see host addition is in progress. See, it's already in the adding stage 80%. Similarly, we can add a other host also. Let's choose the same one and the name is ESX2. So most of the real-time scenario, they prefer to add with a host name only. So only condition is once you update the DNS records, you can easily add with a host name. Okay, second host adding also in progress. And similarly, I'm just adding a third ESXi host. ESXi03, next, and login credentials. Click on next. Yes, next, finish. Okay, so three ESX hosts are added to our vCenter server. Now, if you want to create one empty cluster also, we can create the cluster. So in order to create the cluster, right click the data center, you can choose new cluster. Okay. Suppose if we select the top hierarchy, here we have options to create data center and folder only. In order to create the cluster, we need to come to the data center, right click the data center and choose cluster. Okay. So select cluster, and the cluster name you can give any name. Already we given the data center name as production, so cluster name also we can give the same name, production cluster 01. Suppose in future if we create multiple cluster, production cluster 2, like that we can create. And these features will enable even the vSAN also. I will show you in the next classes. Click on next and click on finish. So now one empty cluster also created. If I go to the summary tab, nothing was there, no processor. Now this processor count will increase only when we add the host. Suppose try to observe the processor count now. If I add the first host, let's just drag and drop. When we drag and drop, see the under the cluster, one of the host is added. You can see whatever the host CPUs we have. If I select the host, how many CPUs here? Logical CPUs are 4 CPUs. The same 4 CPUs added to the cluster. Okay. So cluster is nothing but a grouping of multiple nodes, grouping of multiple ESX hosts. Anything you can say, either node, host, or host, ESXi host. Just a grouping of multiple nodes. Now similarly, I'm adding the second host. If I add the second host CPUs also will increase here. Okay, that means it will add it as a 4 plus 4, 8 CPUs. Just drag and drop it here. See, now the CPU count is 8 CPUs. Whatever the host resource we have, all the resource is become a group of cluster now. Okay, and not only CPU, even in the right side, if you see the memory also increasing. Let's increase the font here. Even in the memory also, if you see, the memory is 16 GB per host. When we add two hosts, total capacity is 32 GB. Okay, that's how the memory also increase. And similarly, we can add the third ESXi host also. Just drag and drop here. So third ESX adding also in progress. If you see, the CPU count is increased and even the memory count also. Now if you see 316, 16 plus 16 plus 16, total size is 48 GB. Okay. And there is a warning symbols. Normally the warning symbols refers as a, we already enabled the SSH as per security conditions. It's recommend to disable, but it's anyhow it's a test lab. You can ignore this warning. Okay. I just suppress the warning. click on yes. These warnings are expected, just to safely ignore. And warning, suppress warning. Okay, but if I select the ESX host summary tab, you can see the one message is no data stores have been configured. Even if I go to the select the ESX host, right side data store tab, there is no virtual machines. There is no data store, and even the virtual machine tab, there is no virtual machines. Same for ESX2 and ESX3. Okay, so now today, as per our discussion, we are going to configure the local storage. If I want to configure the local storage in the real-time scenario, our physical ESX box must have a additional hard disk to add a local storage. Okay, but here our ESX is running on a virtual machine. So in order to add the additional disk, the only option is select our ESXi host, right click and add the new hard disk. But here, while adding the new hard disk, what I'm thinking is I'm just adding the hard disk here, and to update the changes on the OS level, it require a restart. Okay, we know already how to add the ESX host. Hard disk how to add to the virtual machine. Just select the add, and within our hardware components, choose the hard disk and click on next. And see, just now we verified the hard disk types. IDE, the IDE means integrated drive electronics. SCSI we observed, small computer system interface. So use the default recommended one, click on next and create new virtual disk. And the size, let's say, let me check our local disk space first. Okay, in our C drive, we have a 747 GB free. So we are good to assign. Let me try to assign 50 GB first. Okay, 50 GB I'm assigning. Click on next. So hard disk is .vmdk. Click on finish. So click on. So this is the first ESX. Similarly for second host, go to the VM settings, add, select the hard disk, next, 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 and choose the as a store the virtual disk as a single file, and I'm giving the same size 50 GB. Click on next, next, finish. So second hard disk and same way for ESX3. Click on add hard disk, SCSI, create new virtual disk, single file, 20. Click on next, next, finish. So click on OK. Okay, so 3 ESX host, we added a additional local disk. So for this local disk, to apply on the OS level changes, the recommendation is we have to restart. Okay, so OS level, normally for Windows we can do hot add, but this ESX level it won't update by default. It require a restart. Okay, so to restart, just right click the host. You can restart from here, restart guest, or you can connect to SSH and restart. Any method you can use. So let's say I'm restarting from here. Power restart guest, and same way ESX2 power restart guest, and ESX3 also power restart guest. Let's monitor the reboot status. When I select ESX1, see already it's restarting. ESX2 also reboot in progress. ESX3 also reboot in progress. I'm just monitoring the host, which one is first come up. Okay, ESX1 is up. It is showing the 4 CPU, 16 GB memory, and ESX1 71 is up. Let's verify ESX2. ESX2 also up, and ESX3 also up. Okay, now let's go to our vCenter server. We'll try to add the local storage. So ESX1, if you want to add the storage, select the ESX, go to the storage tab. Currently no items found. We are just adding the new local storage now. So how we can add? Select the actions. Under the actions, we have to choose storage, new data store. So only the naming is data store. So select new data store. There are multiple types. today only we just discussed the introduction. ESX host supported mainly two file system, VMFS, NFS. So VMFS means virtual machine file system, NFS means network file system. Apart from VMFS and NFS, there is also another mechanism we can store the VMs, that is virtual volumes. Okay, so for local storage, if you see the point here, create a VMFS data store on a disk or LUN. LUN means logical unit number. So VMF is more suitable for local disk or LUN. And NFS, create NFS data store on NFS share over the network. Over the network only we can access this storage. And vvol is create a virtual volume data store on a storage container connected to the storage provider. This storage provider can be any of the third party storage like HP Nimble storage, NetApp storage, EMC Clarion storage, Dell storage, any storage you can use. Okay, that storage container will help you to create a virtual volumes. Okay, and NFS share will provide a NFS volume. Now tell me, for our local disk, which is the recommended option to choose, VMFS or NFS or vvol? Which is the relevant option for local disk?
VMFS.
VMFS. So select the VMFS. We are going to add a local disk. Okay, so now click on next. See here, it is showing the disks as a, our 20 GB is a local disk. Now the 50 GB is the, we are trying to add now. So select that 50 GB disk, click on next, and VMFS version. If you see the VMF versions, previous VMFS version is 5, even in our ESX version is 7, but VMFS latest version still is 6 only. Okay, so even the interview they will ask what is the latest VMFS version. Remember, it's a 6 only, but ESX latest version is 7. Okay, and VMFS 6 enables advanced format 512E and automatic space reclamation support. Reclamation means whenever any of the virtual machines are not needed, if you delete the virtual machine, even the data store level also, it will clean up automatically. That is nothing but a reclamation. We can reclaim our storage. Okay, and VMFS 5 enables the 2 plus TB LUN support. It supports up to 2 plus TB, but more than that means we should go for a VMFS 6. Okay, select latest version file system and click on next. And partition configuration, see partition configurations, if you want to assign only less size, we can assign less size. Currently 50 GB is empty. If you want to configure for only 40 GB, you can configure 40 also, because if you configure 40 means later in future if you want to increase, we can increase. Let's say for example I given as a 40. Let me type. Okay, I just given as a 40 GB. Okay, we have still 10 GB is available. Now click on next. See, this is the name, data store name and local virtual disk. This is actually partition number. Same like our network card have a unique MAC address, physical address, right? Even our local disks and LUNs also have a unique address. Okay. Even today we discussed about one point is storage is connected to HBA card. HBA means host bus adapter. Similarly, our virtual machine HBA number is starts with a 0, and the remaining numbers and all I will explain in the storage SAN storage class. Okay, so now click on finish. It's a 40 GB size and partition format, and also block size is 1 MB, space reclamation granularity 1 MB, and the reclamation policy also. We'll choose the default options, click on finish. So in the recent task, it's completed. Create VMFS data store. When you see in the recent task, it's completed. Even here data store is added, and you can see data store name created and the name is VMFS. For your easy understanding, if you want to rename, just select here. You can choose rename and mention as ESXi01 because our host name hyphen local data store. Suppose in future we no need to confuse. It's like a our ESXi host local data store only. Click on OK. And same way we can add the storage for ESX2. See in the ESX1, see now there is no warning icon. Warning icon got cleared. But in the ESX2 and ESX3 still there is a warning icon. If I select the ESX2 summary tab, the warning mainly for no data stores have been configured. This is the reason it is showing the warning message. Okay, so now same procedure. This time will go bit faster. Just go to the action. There is storage, new data store, and select VMFS, click on next and choose the 50 GB. For this one, I'm just adding the complete storage. So data store name ESXi02 hyphen local data store. Okay, this is the name I'm giving 01. And okay, now after selecting the name, click on next, next. Our size is, let me back. So select 50 GB, click on next, VMFS6, 50 GB I'm giving, next. See, our data store name is ESX2 local data store. Okay, click on finish. See, our ESX2 local data store is creating completed. The file system also updated to VMFS6. The status will update soon. Let's refresh here. See, now it's the status is normal. Even the ESX2 warning also cleared. Same way for ESX3. Go to the action, data storage, new data store, and choose VMFS. Select the, why it is showing only 20 GB. Let me check our virtual machine. I given only, oh, I given only 20 GB. So that's why it is showing the 20 GB. Okay, go to the storage, new data store, click on next. See here T0, T1. So T0 is the operating system, T1 is the our new disk. So selecting the T1. So ESXi03 hyphen local data store 01. Even if you want to put to hyphen, you can quit. Now click on next, VMFS6 next. So hope you understand the how to add the local data store. See data store, third data store also adding in progress, and this warning will be cleared soon. Let me refresh. See the warning cleared for 3 data stores. So in our previous session, we observed the, let me open our spreadsheet. We observed WAMI data center. Even today also we created data center host and clusters, VMs and templates. Similar to VMs and templates, there is a another tab in our vCenter. In our vCenter, see host and clusters, this is the tab, and VMs and template, this is a tab. If you want to see all your data stores, the tab is data store tab. So this is the icon for data store. You can just click on data store. You can see new data stores. Expand the data center, see data stores. Why I given ESX123 is it's easy to segregate. If I see put the same name data store 123, vCenter clearly say the name is already exist. So we always maintain a different name. For our first ESX, this is the data store. Okay, and even select the data store right side. If you go to the host tab, you can see the ESX1. Similarly, ESX2, ESX2, ESX3, ESX3. So this data store tab always show you whatever the data stores are available, all the list you can find from this tab. Okay, and suppose if I select the network, you can find whatever the network ports are available, all the ports information you can find. Currently we have 3 ESXi hosts, but no virtual machines are created, only one VM network is available. Okay, and there is no even here we have an option to create and all. During the network DV switch concept, I will explain detail. So the next session will be, we are focusing on the NAS. So today we just discuss the basic one. Okay, let's go back to our slide. See, in our vSphere storage, we discussed about the local storage concept. In our next class, we'll discuss about these 3 storages. NAS. First, we start with the NAS. Once we understand the NAS, I will explain iSCSI and FCSAN. After that, I will start with the vSAN and vVols. Okay. So each session may take 1 hour session for each topic. Okay. So the tomorrow session will cover with the NAS storage. That's it for today. If you have any questions, let me know. If no questions, we can end the sessions here.
Thank you, sir.
Yeah. Thank you. Thank you, Shivangi.
Thank
Thank you, everyone. Thanks for your time. Bye for now.